In this video, we are going to show how to do a analysis of variance using RStudio. So for this example, we already have a data set that is showing what is the percentage of savings in shares for 4 age groups. So we have young people, then we have early middle age, later middle age, and more senior people. And the question here is, does the share of savings depend on the age group? Now, the age group, technically speaking, is an ordinal variable, but we'll treat it here as a nominal one. The age groups are different in size, different in numbers, so it's really hard to do anything else. Now, before we load the data, we load our libraries. So we'll load the standard tidyverse. Strictly speaking, we don't really need it to run the analysis of variance. However, I do use it for reading the CSV files. I use it for rearrangement of the data to do descriptive statistics a little bit. So I will need it in this example. I have another library that I find useful sometimes. It's called Desk Tools, Descriptive Tools. It's a package of mostly different statistical tools, statistical tests that, this is the first time we are using it, but we might be able to use it later on as well, also to help us with some regression and some other diagnostics. So strictly speaking, we don't really need it for analysis of variance, but as I said earlier, I find it useful, so we'll load this one as well. Okay, next thing, we load the data. So the data is this about investment dot so ANOVA CSV. We'll just call it investment, like this. And now if we take a look at this data is actually wrong for doing this kind of analysis. Namely, we would like the arrangement of the data to be such that we have two variables. One is the grouping variable and the other one is the interval variable that we want to test. Now what we have here is we have basically 4 variables. So for each group we have 1 variable. And what is more, as you might see, we don't have the same number of observations in each group, so we have quite a lot of NA, so not available, so we have quite a lot of missings because, the number of observations, so 131, is based on the largest group here. So we need to do something with it. And what we'll do is we'll do a pivot. So we'll just make a new data table called investment pivot. So we take investment, then we use something. So this comes from another part of tidyverse. It's called tidier. So if you want to take a look, so this comes from tidier package, part with tidyverse. And it can be actually intermixed with the deployer commands. So particularly in this case, it's intermixed with deployer commands, and the uses from tidier are exactly the same as the uses for deployer. You can see the pipes there that you read as then. So you don't even have to worry about it. Just load the tidyverse. You'll have both available, and you can intermix them. So we need to pivot longer. So basically, we need to pivot in such a way to make a table longer, not wider. So you have the other option is pivot wider. We want to make it longer. Basically, we want to do this for everything. So for all variables, so names of the variables will actually become a new variable that will be called age group. And the values that are there will actually be allocated to a variable that will be named shares. And then just for tidying things up, I don't want those nasty not availables there. So basically, if there is a not available in shares, I will drop it. So this is the last thing I will do. So drop non-availables in shares. Yeah, that's it. So if I run this, if you now take a look at this data, so you have 366, and this is how it looks like. So, and I have no missing. So the zeros are like real zeros. So basically, this person has no savings in shares. Okay, so this is pivoting. Then we can take the averages. Again, I like to do it with deployer, so I group by age group, summarize. So I want for each age group, I want the mean and I want the standard deviation, and well, why not the number of observations. So if I run this, what I get is, so you see you have 4 age groups. So as you can see, early middle age, late middle age, and senior, they have pretty much the same amount, so just over 50% in shares. Also standard deviations are pretty close. Whereas young people have a somewhat smaller share, so not like a big difference. Also a little less of the standard deviation, but it's there somewhere. Now, one of the assumptions of the analysis of variance is that the variances are the same, so these numbers should be pretty much equal, which there are. And then basically for running the analysis of variance, you just have, AOV, analysis of variance, specify the data, specify the model. So the model here is just, it's a one-way ANOVA, so an interval variable shares. Wiggle being dependent on the age group. Just humor me for a minute. So I'll just run this. So I want this, assign this to an object. I'll just run it so that you'll see the output here. As you can see, if you just run this, you don't get the full Fisher table. So actually, to get the full Fisher table or the full analysis of variance table, what you actually need to do is you need to create an object. So you need to assign this model, analysis of variance model, to an object. I'll just call it AOV1. And then request a summary of this model. And the summary of the model is what will get you the familiar ANOVA table, where you have degrees of freedom, sum of squared differences. So you have the between groups and within groups. Within groups is called residuals here. That's the within groups. And then the mean square, so sum of squares divided by degrees of freedom, you get a mean square. And then if you take this number divided by this number, what you get is you get the F value and the one-tailed probability. So what is assumed here is also always so you need to have the between groups variability bigger than the within groups variability in order to claim that the interval variable, so shares in our case, really depends on the factor, so age group. And yeah, well, one-tailed test, and it's significant at 4%. So yes, we can definitely say a yes here, that not all age groups invest the same in shares. So age groups do affect the share of savings in shares. However, it doesn't really seem like a strong effect. We did a quick check earlier for the equality of variances. So, but if you want to run a test, you have this Levine test. This is one of these tests that actually comes from the desk tools. That's why we actually run it there. So the Levine test, if we want to check, are the variances equal? So the null hypothesis here is variances are equal. The alternative hypothesis is they are not. Well, they should be, so you would expect this test not to be significant, and actually the significance for this test is 0.88 or 0.89, way above 0.05. So yes, this is not significant, so there's no reason to claim that variances are different, which is good. And then you have some of these post hoc tests So check some lectures in order to find more about them. You have a whole bunch of them generally. Here in R, one is actually, so the Schaefer test is from Desk Tools, whereas the Taki HSD is from the pre-installed stats package. So there are two variants. So TAC is a little bit stricter, so it will find less significant differences than Schaefer. So if I run the Schaefer first, you see what it does. It actually compares group to group, but it's not like a pairwise comparison. So you sort of try to avoid this double counting for mistakes. But anyways, if you check this one, so the Schaefer here, basically Schaefer doesn't really find any significant differences. So the closer one is between the young and early middle age, but even that one is not really significant. Whereas if I run the Taki finds that particular difference significant, but nothing else. So, well, as we guessed, so different ages probably do save a little bit differently, but the differences are not that big. But that was a short video on how to do analysis of variance, one-way analysis of variance in R. Thank you for your attention.